What does it actually feel like when your multi-agent system works for the first time? Pure adrenaline. One bot scraped the data, a second reasoned through it, and a third wrote and executed live code, all in a single chain, no human in the loop. It was the moment the whole orchestration pattern finally clicked. But then the token rotation collided with the cron scheduler. The Discord bots hit rate limits, and the whole sprint stalled for hours. This week was a masterclass in how fragile multi-agent systems really are, and I'm breaking all of it down for you right now. Here's what nobody tells you about building multi-agent systems. Every new agent you add doesn't just add complexity linearly, it multiplies the failure surface. I hit two brutal problems back to back. First, token expiry warnings started firing on my paid tier bots mid-sprint, and I had to rotate credentials manually, which killed momentum for hours. Second, during high activity periods, my Discord bot team slammed into API rate limits, and I had no backpressure logic in place. Requests were just dropping. These aren't edge cases. These are the everyday realities of running agents in production, and most tutorials completely skip them. Two ideas came out of those painful moments, and I think they're going to define how I build going forward. Number one, a centralized credential manager where every bot has its own isolated rotation cycle. No more shared cron jobs triggering collisions. Each agent authenticates independently on its own schedule. Number two, a unified agent bus, an async message layer that sits above all the individual bots and coordinates task routing without them stepping on each other. Think of it like an event queue for your entire agent team. Both of these are directly inspired by how Google and OpenAI architect their internal systems at scale, and the trending open source world is moving this direction too. Let me walk you through the orchestration pattern that finally clicked. Agent 1 is the scraper, right? It pulls raw data from external sources and drops it into shared memory. Agent 2 is the reasoner. It reads that memory, analyzes the data, and produces a structured decision or summary. Agent 3 is the executor. It takes that output, writes code if needed, runs it, and logs the results. Memory persists across all sessions. So the next time the chain fires, it has context from everything before. What's wild is this same pattern maps directly onto what you see in trending repos like MathCode and WorldX on GitHub right now. The world is converging on this architecture. Okay, let's talk results, because this week actually delivered. My paper trading bot is, on day 2, running 18 strategies simultaneously on a paper account, and roughly 13 of those strategies are showing positive P and L. That's about 70% green on day 2. Not financial advice, but that's a strong early signal worth tracking. My chess app is holding steady with 2 paying pro subscribers and 0 churn. Small number, but 0 churn matters. And the full 6-bot Discord agent team is live across 2 tiers with basic backpressure handling now in place. The next idea I'm exploring, piping the trading bot's signal logic directly into the Discord team, so it auto-posts analysis. That's the dream. There's a news story circulating right now asking, what should we do when code is cheap? And I think the answer is exactly what this channel is about. Stop optimizing for writing code and start optimizing for system design, failure handling, and knowing what to build in the first place. The builders who win aren't the ones who generate the most code. They're the ones who understand orchestration, constraints, and real user problems. If you're building AI agents right now, drop your biggest struggle in the comments. Rate limits, token issues, orchestration chaos. I want to hear it. Subscribe if you want the real week-by-week journey, not the highlight reel. See you next week.